All right, so this pendulum problem, you've got the object down here at the bottom, and this is like when you go swing. Remember, I told you for your summer assignment you were supposed to swing. That was so that you could experience this change in energy, the transfer of energy. Now, does the length of the string or whatever, does it change? No. So this is L, the whole length of the string, and this is L. And I use like a script L because a Times New Roman L looks like a 1. So you can use a capital L or you can use an L like that, but those are lengths. Okay. So it swings through, and as it swings through, it's convenient to let your the lowest point of the swing be where y equals 0. So let this be where y equals 0. It makes everything easier to do, so to speak. So let that be y equals 0 down there. Okay? So then that means the height that the pendulum has traveled, its y, is this distance right here above the ground. And we need to find that in order to find the potential energy it has when it is up here. I mean, when you go swing, you put your bottom in the swing seat, you walk backwards, right, until it's above the ground, and then you pick your feet up. So what you've done to your center of mass by picking your feet up is you put your center of mass, I don't know, the length of your legs above the ground, and then you've got some potential energy. And then you swing your torso and your feet back and forth, and that causes the swing to swing higher as you're changing your moment of inertia and forces and all that kind of stuff. It's kind of cool if you get into all the dynamics of swinging. But this y, okay, is the height. And that's what we need to find. We need to find that y in order to find the potential energy of the object. Now, play with me here. Let's see. What if I were to, I'm going to make this dotted, make a line that is perpendicular right there, nice and perpendicular, parallel to the ground, all nice and perpendicular. Okay. Would this length right here, would this right here also be y? Yeah, that's my y that I want to find. Okay? Now let's see, L is the whole thing, y is this piece. So could I find maybe this right here, the side of the triangle? I was trying to highlight it there. The side of the triangle in terms of theta, and oh look, it's hypotenuse, L. So this side is what compared to that angle? Adjacent, and so the cosine of theta would be the adjacent side. Oh, let's give it a name. Let's call it D, because I don't know what else to call it. So L is the whole thing. Y is the height that the pendulum bob or the swing kid of science has gone up to, whatever. And D is this weird length right here that doesn't really matter, but it's going to matter a lot in finding the answer. So the cosine of adjacent, D over L, therefore D is equal to L cos theta. Ooh. So then what is L? Wouldn't L be D plus Y? Okay, so L is equal to L cos theta plus Y. So does that mean that Y is equal to L minus L cos theta? That right there is so important for your success in the pendulum problems. It comes up a lot. Okay, I would just, you can derive it every time, or you can put it on that list of equations that you like to use. That is how to find the height for Tarzan. I call it the Tarzan problem sometimes, because Tarzan swings on a vine like that. So that's the height.